Would you like to learn about segmentation and microsegmentation to enhance your cloud security architectures? If so, this video is for you. Hi, my name's Mike Gibbs, and in today's video we're going to discuss segmentation and microsegmentation. We'll describe what they are, and then we'll give you some best practices to enhance your cloud security architectures or your cloud security posture, and even your multi-cloud security posture. So we're going to begin with what is segmentation. And segmentation is basically dividing your area, your environment, into multiple boundaries. And the reason we might divide an area or whatever that is into multiple boundaries is to do something that we call reduce the blast radius. For example, if something happens here, it won't happen over here. Hopefully, that's what we're trying to do, is contain the challenge. So let me walk you through a few examples of traditional segmentation. So in this example, we have a traditional switch. Let's say the switch has, say, 50 ports on it. And we created a VLAN which has 10 of those ports. Now, all of those servers and those 10 switch ports can be able to speak to each other, but they won't be able to speak to anything in VLAN 20 or 30 unless they go through a router. So we could put development and testing on this VLAN, and we could actually put production on this VLAN. And if something happens on this VLAN, theoretically, something should not affect the other VLAN. So that is one form of segmentation. Now, you may see another form of segmentation as you're in the cloud computing environment, and you have one VPC or VNet for your internet-facing applications. And here's why you might do that. This part has to be exposed to the internet. And you might have another VNet for all your private applications that you're connecting to over a private line, whether you call it, say, a direct connection or an express route or a direct interconnect, depending upon the cloud provider. But these things are all internal and not even exposed to the internet. So that might be a way we could segment our network. Now, we could also have segment our let's say we're all on a single VNet. We could basically have an ACL between these these actual subnets that we have over here. If they're both in the same VNet, we could segment it with an access list, would be another potential thing. So there's a lot of ways to segment these types of environments, and segmenting is to reduce the blast radius to enhance the security. Now, microsegmentation is a little bit different. We're going to further segment. We're going to segment at the workload, for example, at whatever the service is, and even at the process level. So we're going to have a much greater level of security. And we need this in cloud computing because the boundaries are softer compared to the data center. So we need to know that everything is secure, which tends to bring us to those zero trust type frameworks, and microsegmentation is a critical component of zero trust. So let's talk more about that. So we basically want to define a policy where we can apply labels to things, and that policy will affect things from a security perspective, and I'll show you how we might want to do that as well. We also want to use identity to determine who's allowed to connect to whom and what they're allowed to do, and obviously track it with your typical IAM type things in every session that's going from one system to another or a person to a system. So by enforcing things at the workload level, we can make sure that two servers in the same potential VLAN can't even speak to each other. And we're going to segment with things like security groups or network security groups and firewalls, network policies, and we can even put some of this in policy as code in our CI/CD pipeline. So now let's talk about how we can design segmentation into our architecture, specifically in cloud computing. Well, one of the first things we want to do is define what I call a strong macro boundary. And this is a boundary we want to create at the organization's level, potentially even the subscription level at the cloud provider. Let me kind of show you what I mean. We want to create a hard boundary where we can regulate who's able to do what. We may segment by business domain. We may separate based upon compliance scope. But let's look at an example. This is typically the way AWS organizations would work. All the cloud providers have something that designs this. So at the top level over here, for example, where we see the organizational root, that would be the master account owner for the organization. Now, at that level, this is the master account. And what we can see is we can create multiple organizational units beneath that, which I'll talk about in a second. But the key is this is the master level. Now, at the master level, if we desire, we can create a policy at the organizational unit level, which is what I tried to show over here. We can create a policy at the member account level. We can create a policy at the root level. So we're creating policies here that could be inherited further down the line. And why are we doing this? Because this may be one company, this may be a division of the company, and underneath the member accounts, there's various services that would exist underneath these accounts. And we're doing that to create the boundary. AWS calls it organizations. Azure calls it subscriptions with enterprise landing zones. When we go to Google Cloud, they call it folders and projects under the organization. But the concept is the same. We're enforcing guardrails from the top. And whether AWS calls it a policy or Azure calls it a policy or Google calls it organizational policies, it's the same thing. And we can even automate the provisioning of these with infrastructure as code. Now, we can also do some network segmentation in the cloud and across the cloud. And let's talk about ways we might actually do that. Often we use a hub and spoke model, and I'll show you what this typically works with. And there's many ways we can actually do this. But let's say, for example, we segmented our environment into the VPC-A, that is the production VLAN, and another VPC that's the development and testing VLAN, and this other VLAN or VPC is, say, finance. And in this case, I was calling it a VLAN because that's what we might call it in the data center, but here we could call it a VPC in the cloud provider. Obviously, a VPC is more than just a VLAN, but it's a boundary term. So what we can do is we can set this up that what we're trying to be sure of is the following. When this VPC wants to connect to something, that thing is typically here, the DNS, but we can also have some traffic inspection so we can actually see what's going on and inspect traffic as absolutely necessary. Now we can also make it that this VPC can access something central in the hub, and but this VPC, for example, can't talk to this VPC. So in this manner, if we wanted to and align it this way, which is something we often do in a hub and spoke specifically, is we create spokes that can't talk to each other, but we put them in a central site. And typically, if we need central spokes to talk to each other from a routing perspective, we can enable that too. And then we can inspect the traffic that's going back and forth to make sure that it's exactly what it should be. So we think in the hub, DNS, identity, logging, good, strong, and section. So we want to actually do that. Now, also want to lock down any routing between subnets that doesn't need to occur and prevent that from occurring. And we want to be very careful, obviously, with internet-facing traffic. Anything going through the internet, obviously, we'll need to have at least one layer of firewalls off, and you probably need some layer 7 inspection as well from, say, an IPS IDS system. And of course, we've got firewall rules that can help us do these things. But whenever we create a firewall or an ACL, let's just understand there's that default deny, and we allow only what we want to let through. So that's one of the things we can do from a network perspective. We can obviously go out to the internet less and use the equivalent of a private line across them, whether we call them private links or other things like that. So that's something we definitely want to do. Now we can microservice. We can actually microsegment at the actual workload level. And here, maybe we'll draw this one out real time. Maybe this will be a fun one. So let's say we've got two systems on the two servers sitting on the same subnet. And this is server A. And over here we have server B. Now they are both on the same subnet, which means by default, they could actually talk to each other. But what we can do is each one of these obviously has that virtual network connection, that virtual network card that needs to sit on every virtual machine. And even if these two servers are on the same subnet, what we can do is we can put in a security group on this, which is the equivalent of a host-based firewall that'll allow whatever traffic comes into here is allowed in, but not to this host that's both sitting on subnet A, because we can really lock it down at the network level. So think about that. Now, when one workload has to touch another workload, we want to do it at the least privilege possible. Now, we need to think about that. We want to make sure that every server we have has all the ports closed except for the ones we need. So we're really, really looking at that workload to harden the workload and make sure that those workloads are there. Maybe put some endpoint detection and response as well on the workload level. But we're getting very granular, directly, all the way, just directly right before it even hits the server, or right before it's even going to hit the load balancer of the servers. And if we have any Kubernetes in our environment, just assume it's open and insecure by default. So, it allows, we need to lock that down and lock it down. Segment by namespace, segment via app tier. But realistically speaking, make sure you lock it down. Turn on service to service trust and do what's necessary to do things like that. And bake your policies into your pipelines. And constantly observe and iterate. Now, identity is another place where we can micro-segment. So, we are going to bind access into the workload identity itself. Whenever supported, target rules to service accounts like a server-to-server type account with a managed identity. Label absolutely everything. Data class, app tier, and make labels the source of truth for policy. So things are correctly labeled and we can apply policies to that. Really try to centralize the intent and enforce locally. So keep things enforced in a manner that's going to work. And whenever we think security, just deny by default. Permit only what we allow. And let's say we've got to go to a cross-cloud environment. Well, that's okay too. Make our policy portable. Drive rules by labels and tags and identities. Create a fairly simple policy matrix so we can think of what we're doing. So we've got one source and we can move what we need to and keep that actually out there. And again, enforce things at the workload. Micro-segment on the security group, micro-segment before things actually cross the cloud-to-cloud wide area network, send what needs to go and not what doesn't need to go, and filter who can speak to. And realistically, standardize on intent. And make sure that we've got a standard intent, a standardized way of doing these things, typically speaking, a standard set of tooling, and you'll be pretty good to go. Can we play a little more with policy? Yeah, policy as code guardrails should absolutely be there from a governance perspective and an automation perspective. We should have guardrails that actually have some form of drip detection, so when things aren't what they're supposed to be, do something about it or remediate it fairly quickly. Let's instrument everything we've got. And whether it's a VPC flow log, something from our traffic site in AWS, whether it's a firewall log, whatever it is, send it to some form of SIEM and source system, ideally that will work with all your cloud providers and data centers that you're possibly using, and constantly test and get better. So if we do this right, we reduce the lateral movement that we have. We reduce the blast radius if an attack were to occur. We get better resilience and isolation from each of the departments that we have, which ultimately leads to enhanced security and reduced exposure to major challenges. I hope you enjoyed this video on segmentation and micro-segmentation in cloud security architectures. If you desire to become a cloud architect, enterprise architect, security architect, an AI architect, or any kind of architect, we run free weekly architecture webinars twice per week. We run them on Zoom, typically speaking. And on these webinars, we'll discuss what we do as, say, a cloud architect or an enterprise architect, the skills you need as a cloud architect or an enterprise architect, how to stand out and get hired as a cloud architect, enterprise architect, security architect, and get that first architect job. And of course, it's on Zoom, so you can ask me any questions live that you want, and we'll do anything we can to help you. You can sign up for one of these free architecture webinars by looking in the description of this video. There'll be a sign-up form for it. If you enjoyed this video on segmentation and micro-segmentation to enhance the security of your cloud architectures and your cloud security posture, please give it a like, subscribe to our channel, and hit the bell to be notified of new videos to help you in your architecture career. And if this video helped you, please share it to a friend and let them be helped by in their cloud architect career, security architect career, or other architecture career. This is Mike Gibbs signing off for now, and I hope to see you soon. Take care.